Swayam Prabha. Digital India. Educated India.
Welcome back. So, now let us see how to find out the solution of PDE using the Fourier transform. One more example on Fourier cosine transform, so that you become familiar with the solution process. The problem is equation is given as del u del t equals del to u del x square x greater than 0 t greater than 0. It is given that u x 0 t equals 0 when t greater than 0 and u x 0 equals x whenever x lies between 0 to 1 and 0 for x greater than 1, u and del u del x approaches 0 as x approaches infinity. So, from the given condition, again del u del x approaches 0, u x 0 t is 0 is given, u x 0 is given. Therefore, I have to apply the Fourier cosine transform with respect to the variable x, not with respect to the variable t. So, your equation here again was del u del t equals del u del t equals del to u del x square. So, if you apply Fourier cosine transform with respect to x on the given equation, so you will obtain root over 2 by pi 0 to infinity del u del t into cos of alpha x dx. This is equals to root over 2 by pi 0 to infinity del to u del x square into cos of alpha x dx, which gives ddt of u bar c. Left hand side will be nothing but 0 to infinity u cos of alpha x dx, which is again u bar c, and on the right hand side again if you integrate you will obtain root over 2 by pi del u del x into cos of alpha x 0 to infinity plus alpha into 0 to infinity del u del x into sine of alpha x dx. And for the, please note that del u del x, it is given two things. One is u x 0 t is 0 and del u del x approaches 0 as x approaches infinity. These two conditions are provided. U x 0 t equals 0 and del u del x approaches 0 as x approaches infinity. So, if I substitute these two values, then this particular term will vanish. You will have only the second integral, that is root over 2 by pi into alpha into 0 to infinity del u del x into sine of alpha x into dx. Again, if you break it, you will obtain d dt of u bar c. This will be equals to root over 2 by pi alpha into u sin alpha x 0 to infinity minus alpha square into 0 to infinity u cos of alpha x dx. And this value will be equals to minus alpha square u bar c, with the condition that u approaches 0 as x approaches infinity. We know this thing, u approaches 0 as x approaches infinity. Therefore, this value, this term will vanish, and the next term alpha square into root over 2 by pi 0 to infinity u cos of alpha x dx is nothing but u bar c. So, that your equation, differential equation becomes d u bar c dt plus alpha square u bar c, this is equals to 0, and the solution of this one is u bar c equals a into e power minus alpha square t. I have to find out the value of the constant a now using the similar process, that is at t equals 0. What is the value of u bar c alpha 0? From the definition, this equals, you can write down root over 2 by pi 0 to infinity. This is nothing but u x 0 into cos of alpha x dx, because u bar c is this. So, cos of alpha x dx. So, this equals root over 2 by pi. The function is defined from 0 to 1, it is x. So, u x 0 is x, it is given from 0 to 1. So, it is u x 0 equals x cos of alpha x dx. So, u bar c is nothing but the Fourier cosine transform of the function u x 0. For that reason, we have written 0 to infinity u x 0 cos of alpha x dx into root over 2 by pi is u bar c alpha 0. Now, u x 0 is 1, in 0 to 1 u x 0 is x and otherwise it is 0. So, that you will obtain 0 to 1 this thing. If I evaluate this integral, you will obtain root over 2 by pi x sine of alpha x by alpha minus 1 by alpha square into minus cos of alpha x 0 to 1. If I evaluate the limits, then ultimately I will obtain sin alpha by alpha plus cos alpha minus 1 by alpha square. So, once I am obtaining this, therefore, if I substitute it in the given equation, this e power term will vanish and your a will become this term only. That is, your a is now from here, if I substitute root over 2 by pi sin alpha by alpha plus cos alpha minus 1 by alpha square. So, u bar c, this will be equals to root over 2 by pi into sin alpha by alpha plus cos alpha minus 1 by alpha square into e power minus alpha square t. And once I obtained u bar c, I can always write down u x t using the inversion formula root over 2 by pi 0 to infinity u bar c into cos of alpha x into d alpha, and you put the value of u bar c is your root over 2 by pi into root over 2 by pi will come here, then sin alpha by alpha plus cos alpha minus 1 by alpha square into e power minus alpha square t into cos of alpha x into d alpha, and I can evaluate the integral to obtain the value of this one. Sorry, one thing I missed, that is this is from 0 to infinity, the integration from 0 to infinity. So, u x t is this integral. If I evaluate it, I will obtain the result. Let us see quickly over here. The problem was given as this one. So, what I am doing? I am just taking Fourier cosine transform, then using the earlier methods I am evaluating the integral, and in evaluation of the limit we are using the condition u x 0 t is 0 and del u del x approaches 0 as x approaches infinity. So, that again evaluating I am ultimately obtaining my ordinary differential equation as d u bar c dt plus alpha square u bar c equals 0, whose solution is u bar c equals a e power minus alpha square t. So, I have to find out the value of the constant a. For that one, I am finding at t equals 0, what is the value of u bar c alpha 0. So, this is this integral under the integration sin 0 to infinity u x 0 cos of alpha x dx, and we know u x 0 equals x in 0 to 1, otherwise u x 0 is 0. So, it boils down to this integral. If I evaluate the limit, I will obtain this function of alpha, and this is the value of a. Once I obtained a, I can find out u bar c as a function of alpha and t, and from here I can write down u x t is equals to root over 2 by pi 0 to infinity into u bar c cos of alpha x dbx, and you can substitute the value of u bar c over here and you will obtain the required integral. If I evaluate the integral, I can find the value of u x t. Now, let us see the other one. Till now whatever problems we have done, that is using Fourier sine transform or Fourier cosine transform. Now, let us solve another problem using Fourier transform. The function is given as del theta del t equals k del 2 theta del x square. X lies between minus infinity to infinity, t greater than 0 here, and with theta equals f x at t equals 0 and theta and del theta del x approaches 0 as x approaches infinity. So, theta equals f x at x t equals 0 we have assumed, means the result whatever I will obtain, that I will obtain in terms of f x only, and if I substitute the f x by a particular function, I can evaluate the value. So, the general function we have used as f x. Now, if you see the problem itself, here I have two variables x and t. T is given as greater than 0 and x lies between minus infinity to infinity. And you know the range for Fourier transform is from minus infinity to infinity. Also, it has been given that del theta del x approaches 0 as x approaches infinity, and theta also approaches 0 as x approaches infinity. Therefore, from the given criteria, we can tell that I have to use the Fourier transform on this given equation with respect to the variable x, not with respect to the variable t, because range of t is from 0 to infinity, not from minus infinity to infinity. So, we should be careful whenever we are trying to solve a problem. The first thing I have to think which transform I can use. Here, just like since x varies from minus infinity to infinity, I can take the Fourier transform because the conditions are also given, but I cannot use Fourier transform with respect to the variable t, because range of t is from 0 to infinity. So, to solve the problem, basically your equation has been given as del theta del t. This is equals k into del 2 theta del t square. So, apply Fourier transform on both sides. If you apply Fourier transform with respect to the variable x on this given equation. So, left hand side will be 1 by root 2 pi from the definition minus infinity to infinity del theta del t into e power I alpha x dx. So, that it will be a function of x, and right hand side will be k into 1 by root over 2 by pi minus infinity to infinity del 2 theta del x square into e power I alpha x into dx. Now, if you see here the left hand side del t, where this function is a function of alpha and x. So, therefore, del t you can bring outside, and once you are bringing outside, I can make it ddt. So, your integral becomes then 1 by root 2 pi minus infinity to infinity theta e power I alpha x dx, and this is nothing but the Fourier transform of theta. So, that the left hand side you can write down d dt of say theta bar say, and where theta bar is nothing but the Fourier transform of the function theta, which I am denoting as this. And right hand side, now I have to use the integration by parts, and I have to find out the value k into 1 by root over 2 by pi. First term will be del theta del x into e power I alpha x minus infinity to infinity minus I alpha will come over here minus infinity to infinity del theta del x into e power I alpha x into dx. Now, this please note that del theta del x approaches 0, it is given del theta del x approaches 0 as x approaches infinity. So, therefore, in using this part and the second part also, using this condition, this value as x approaches infinity or minus infinity, this term will be vanishing. So, we will have only this term minus I alpha into k will come I alpha k by root over 2 by pi minus infinity to infinity e power I alpha x into del theta del x into dx. And this again, if you evaluate the integral, you will obtain this equals minus I alpha k by root over 2 by pi into, here it will be theta into e power I alpha x minus infinity to infinity minus I alpha into minus infinity to, this will be yes I alpha into minus infinity to infinity theta will come del theta del x will be theta into e power I alpha x into dx. Again, if you note, theta approaches 0 as x approaches infinity. For minus infinity it is 0. So, this term will vanish using the condition that theta approaches 0 as x approaches infinity. So, you will have only this term, that is this minus will be going over there I square. So, again one minus will come. So, minus k will be there and 1 by root 2 pi minus infinity to infinity theta e power I alpha x is nothing but your theta bar. So, that this will be k alpha is there alpha square into theta bar. So, this reduces again to 1 ODE only. So, once I am getting this, I can neatly write down d theta bar dt plus k alpha square theta, this is equals to 0, whose solution you can write down k alpha square theta bar will be there. So, that the solution is theta bar equals a e power minus k alpha square into t. Now, I have to find out again similar process value of a at t equals 0, your theta bar alpha 0, this is equals to 1 by root 2 pi minus infinity to infinity theta x 0 into e power I alpha x d alpha, it will be dx function of alpha, it will be. So, this equals 1 by root 2 pi minus infinity to infinity theta x 0 is nothing but has been given as theta x 0 is your f x. So, f x into e power I alpha x dx. And if you see this, we can tell as f bar alpha, where your f bar alpha is nothing but the Fourier transform of the function f x. So, ultimately you are getting theta bar alpha 0 equals f bar alpha, where f bar alpha is Fourier transform of f x. If f x is known to me, then I can calculate what is the f bar alpha also. So, by using this, if I put it on this particular equation now, this value, I will obtain my a as f bar alpha. So, once I am obtaining my a as f bar alpha, then I can write down my theta bar equals f bar alpha into e power minus k alpha square t. So, that from here you can write down, theta x t using the inverse Fourier transform. This equals 1 by root over 2 pi minus infinity to infinity your f bar alpha e power minus k alpha square t into e power minus I alpha x into d alpha. I will obtain this thing. And if f bar is known to me, then I can evaluate this integral. So, by this way we can find out the value of theta x t. So, let us see quickly over here. The problem is given as like this. So, I am taking the Fourier transform 1 by root 2 pi minus infinity to infinity del theta del t equals e power I alpha x dx, and the right hand side is this. Left hand side is nothing but d dt of theta bar, because you are taking the Fourier transform with respect to x, and for the right hand side you have to evaluate the integral. And by substituting del theta del x approaches 0 as x approaches infinity, I can find out the solution. And as theta x approaches 0, as x approaches infinity, then the limiting value of the first term will be 0. So, that I will have only the second integral. Now, second integral again I am evaluating by using integration by parts, and then this ultimately becomes minus k alpha square theta bar, where theta approaches 0 as x approaches infinity is given to us. So, I am getting the differential equation like this, whose solution is theta bar equals a e power minus k alpha square t. So, I have to find out the value of a at t equals 0, q bar alpha 0, this is equals 1 by root 2 pi minus infinity to infinity theta x 0 into e power I alpha x. So, theta x 0 is known as f x. So, that I will obtain this, and this is nothing but f bar alpha, that is Fourier transform of the function f x. Therefore, your value of a will be f bar alpha, and once I am obtaining f bar alpha, I can find out the theta bar equals f bar alpha into e power function. So, theta t I can write down as an integral like this, and this value is f bar alpha into e power this function. And once I know the f bar alpha, I can tell what is the value of theta x t. Now, let us take another problem. This particular problem earlier, if you remember, we have solved it using Fourier cosine transform. Now, the same problem we want to solve it using Fourier sine transform, and we are saying that it is given that v equals v 0 when x equals 0 and t greater than 0, v equals 0 when t equals 0 and x greater than 0, and v and del v del x both approaches infinity, both approaches 0 as x approaches infinity. So, once I know it from the conditions provided here, and since del b del x approaches 0 as x approaches infinity, I have to take Fourier sine transform with respect to the function x. So, let us see this one. So, you apply Fourier sine transform with respect to the variable x. So, left hand side will be root over 2 by pi 0 to infinity del v del t was there, del v del t into sine alpha x dx. This is equals k into root over 2 by pi 0 to infinity del 2 v del x square sine alpha x into dx. So, that the left hand side will be d dt of nothing but d dt of v bar s, because the integral root over 2 by pi 0 to infinity v sine alpha x dx is nothing but the Fourier sine transform of v, which we are denoting as v bar. And this again following the similar process what we was doing earlier, you will get del v del x into sine alpha x 0 to infinity minus alpha into 0 to infinity del v del x into cos of alpha x dx. Again, this first part will be vanishing, because del v del x approaches 0, this approaches 0 as x approaches infinity. So, therefore, this term will vanish, you will obtain only minus alpha k root over 2 by pi into 0 to infinity del v del x into cos of alpha x dx. And again evaluate this integral. If you evaluate this integral minus alpha k into root over 2 by pi, you will obtain v into cos of alpha x 0 to infinity plus alpha 0 to infinity into v sine of alpha x dx plus v sine of alpha x dx. This first part again will vanish because one part will vanish of this. Please note that v approaches 0 as x approaches infinity, and v equals v 0 at x equals 0. So that this becomes now will be becoming, first part will be k alpha into v 0 into root over 2 by pi minus this will be k into alpha square into v bar s. So, this part extra term is coming over here now. Therefore, from here the ordinary differential equation you can write down d v bar s dt plus k alpha square v bar s. This is equals k alpha v 0 into root over 2 by pi. Once I am obtaining this, I can write down v bar s into e power k alpha square t, solution of this c plus root over 2 by pi v 0 by alpha into e power k alpha square t, and so this is your equation 1. Your at t equals 0, your v bar s is 0. This is why? Because we know that v equals 0 at t equals 0. This is known to us. Therefore, from here you can tell that v bar s is equals 0 at t equals 0. So, if you put it in 1, then from 1 what you will obtain 0 equals c plus root over 2 by pi v 0 by alpha. This term also will not be there. So, that you are obtaining the value of c as minus root over 2 by pi into v 0 by alpha. So, if I substitute in 1 this value, I will obtain v bar s as root over 2 by pi into v 0 by alpha into 1 minus e power minus k alpha square into t. And once I have obtained v bar, in that case I can find out v x t also. This v x t equals 2 by pi v naught into 0 to infinity 1 minus e power minus k alpha square t by alpha into sine of alpha x into dx. This now I can break it into two parts, that is 2 v 0 by pi into 0 to infinity sine of alpha x by alpha into d alpha minus 0 to infinity e power minus k alpha square t by alpha into sine of alpha x into, this is d alpha not x. So, d alpha. This value is known to us pi by 2. So, that this equals, you can write down directly v 0. If I make it, this will be v 0 into, this value is your pi by 2, please note this one. So, if it is pi by 2, this pi will be cancelled. So, that here there will be 1 minus 2 by pi. Please note that this value I have substituted as pi by 2. Please note this thing. So, this will be becoming 2 by pi 0 to infinity e power minus k alpha square t by alpha into sine of alpha x into d alpha. So, my next job is to find out the value of this integral. So, let us start from here. Let your f x equals 0 to infinity e power minus k alpha square t by alpha into sine of alpha x into d alpha. From here you can tell what is your f dash x. Your f dash x I can write down 0 to infinity e power minus k alpha square t into cos of alpha x d alpha. Your alpha will be vanishing, and this is equals to, this value is known to us, and if I substitute this value, this will be e power minus x square by 4 t k. I am using this integral value as a known result. So, effectively what is happening over here, your f x is becoming then 0 to half into root over pi by t 0 to x e power minus x square by 4 t k into dx. And this, if you evaluate again, this equals, you can write down half into root pi by t into 2 root k t, just some modification we are making, 0 to x e power minus x square by 4 t k into d of x by 2 root k t. That is the reason this 2 root k t is coming over here. So, once I am getting this integral, then on this if you put u equals x by root over twice k t, you will obtain your f x as half into root over pi by t into 2 root k t 0 to x by 2 root t into e power minus u square du. Please note this one. This value is known to us, and this equals pi by 2 into error function of x by twice root k t. This we have done again earlier. This integral is nothing but ERF of x by 2 root k t. So that your v x t will be equals to v 0 into 1 minus ERF of x by twice root k t, and this you can write down complementary error function. So, ERF c of x by twice root k t. So, this will be the solution of the given problem. So, let us see quickly over here. Once we are getting this, because the solution process is little different, initial part is same. By this process I am getting the by substituting the initial conditions, I am getting the ordinary differential equation as this, whose solution is written as v bar s equals this thing. And once I am obtaining this at t equals 0, v bar s is 0, since v is 0 at t equals 0. So, from 1 I can obtain the value of constant c I am getting as this. So, that v bar s I am obtaining, and v bar s once you are writing, now v x t you can write down. This you break it into two parts, two integrals. First integral value is pi by 2. So, I am getting v 0 into 1 minus 2 by pi into this integral. My aim is to find out the value of this integral now, which I am assuming as f x. So, that f dash x from here I can find out, and the value of this integral is nothing but is known to us, the common one we have written this. So, that your f x will be nothing but half into root over pi by 2 0 to x into e power minus x square by 4 t k dx. From f dash x you can write down this integral, integrating both sides on the given equation. And if I evaluate this integral, then ultimately I am obtaining this by substituting u equals x by 2 root k t. So, that the value becomes error function ERF of x by 2 root k t as f x. So, your v x t becomes v 0 into 1 minus error function of x by 2 root k t, and this is nothing but V 0 into complementary error function of x by 2 root k t. So, I hope the solution processes are clear to you now.